So here I have Unit 3A's review for Algebra 2. I'm going to go through this and hit some highlights to make sure you know what to study for your test upcoming. So this first page is all about factoring. If you look at it, numbers 1 through 12 are all you're going to do is factor, and we had a variety of ways we talked about this in class. And it is super important that you know how to do them for your test. So I'm going to pick a couple and just talk about them. Please remember that the first thing you should always do is try to GCF. So if you look at number 1 here, there's not a GCF, so you're going to go straight to factoring. But looking at number 2, there is. So like on number 2, I would go through and pull out a 2n squared from everything. So then that'll leave me with n squared plus 3n plus 2. You are not done then. You do have to keep going. And one thing we talked about, when you have 3 terms, this is where we're going to use our x. So you do your first term times your last term. So 1 times 2 gives me 2. And on the bottom you put your middle term, so 3. And we're going to find numbers that multiply to give us 2, but add to give us 3. And this is where sometimes you have to guess and check and play with signs and different numbers and whatever it is. In this example, it's just 1 and 2. Once you find that pair, we're going to replace our middle term with it. So we're going to have n squared plus 1n plus 2n plus 2. And it does not matter what order you put that in. And then we draw a line down the middle and factor by grouping. So I'll pull out an n. I'll pull out a 2. And then we rewrite it in one parentheses. Needs to be your 2 GCFs, so n plus 2. And in the other is what match. So those other 2 parentheses need to match. For this answer to be completely done, we do need to pull our GCF down to it, so 2n squared. This would be completely done. This x method is what you'll use on a lot of things. Pretty much anytime there's a trinomial. That's not going to be perfect, but that will work most of the time. So on like 1 and 5 and so on. On 7, when you have 3 terms, that's what you're going to do. When you have 4 terms, remember that that's really just the easier version of our x factoring. You do need to check for a GCF, but then just draw a line down the middle and factor by grouping. So you'll repeat what happened just here after I had found the pair. When you have 2 terms, it works a little bit differently depending upon what's going on. But if you look at some of these now, we just have 2 terms. For example, on number 10, I have 2 terms, and if you look, both of them are perfect squares. You do always want to check for a GCF, but this one again didn't have one. If we have 2 perfect squares, you have a pattern you can apply of a minus b and a plus b. And to figure out your a value and your b value, we're going to square root this 25x squared and square root the 4y squared. Square root of 25x squared is 5x. Square root of 4y squared is 2y. And so we're just literally going to fill in these 2 terms in for the a and the b. So if you look at the back, what you'll notice the answer is just 5x minus 2y, 5x plus 2y. Do remember as you go through these, the answers are all attached on the back. I'm just going to show you some of the work as we go through this video. On number 4, it's going to follow the same pattern, but you are going to have to factor a GCF out first. Same thing on number 6, but it is a different pattern, so I'll talk about number 6. Okay, on number 6, you can GCF out a 30 from this problem. 240 divided by 30 is 8, so it's 8c cubed minus 1d cubed. And this is not a difference of squares pattern, it is a difference of cubes. So I'm going to write out this pattern. You do have to have it memorized. This is where we did a cubed plus or minus b cubed was equal to a plus or minus b times a squared minus plus ab plus b squared. With this, again, if it was a plus in the original problem, you will use addition here and then subtraction for the second one. You use the top sign for both. If it is a minus originally, you're going to use the minus and then the plus. So with this one, it's a similar process to before. We need to cube root the 8c cubed, which gives us 2c. And we need to cube root the d cubed, which just gives us d. And then we're going to fill into this formula. The 30 stays out front. A minus b is just 2c minus d. The a squared tells you to do 2c squared, so that will be 4c squared, plus a times b, so 2c times d is just 2cd, plus b squared, which in this case is d squared. So anytime you have your cubes added or subtracted, this is the pattern you're going to follow. So again, on 12, it's going to be that same pattern. Again, I cannot stress how important factoring is for this test, so please make sure that every problem on that front page you are confident in doing. And if you need help, come see me before the test. On this next page, we get into the solving, which is also going to be very important for your test. And there's a few different ways we did it. You were given 3 different options in how to solve things, so I'll talk through ones that work out differently so we can see that. Your best option most of the time is to set it equal to 0 first. Okay, if you're not sure what to do, always set it equal to 0 first, because that will help you to see what to do. Like on number 14, I try to keep my x squared positive, so I'm going to move the 2x. It is super important that you keep it in the correct order. So the fact that the 2x went in the middle is crucial. What I always try to do is factor. So I'm multiplying to negative 35, adding to negative 2. And the pair that will do that is negative 7 and positive 5. And then again, you go through this whole factoring process. For the sake of helping you review, I'll write out all the work. So I replace that negative 2 with the pair. From the first 2, I can pull out an x. From the second 2, I can pull out a 5. And so this will be x plus 5 times x minus 7. Now when you are solving, you have to actually give me a number. And so what we talked about was the zero product property, where if 2 things multiply to give you 0, as this does, then at least one of them has to equal 0. So we're going to set both of them equal to 0. When you solve x plus 5 equals 0, you get x equals negative 5. When you solve x minus 7 equals 0, you get x equals 7. So those would be my 2 answers. Now factoring is the easier thing to do, but it will not always work. So I always try it first, but I'm going to find one on here that maybe factoring doesn't work. And on this one, both 16 and 17 actually don't. On the test, it will not tell you what does and doesn't work, so do make sure you listen through this and you know why it doesn't work. So here I'm going to set it equal to 0. And then I'm going to try to factor. So I need to multiply to negative 10 and add to negative 6. Well, the only ways to multiply to 10 are 1 and 10 and 2 and 5. And no matter what I do with that, I'm not going to be able to multiply to to add to negative 6. And if it's impossible, that's where you have to use the quadratic formula. I will not give you the quadratic formula on the test, so it is crucial that you remember it. So your quadratic formula is x equals negative b plus or minus the square root b squared minus 4ac all over 2a. And again, we're going to plug it in. So negative b tells me it's a positive 6 because you flip that sign. Plus or minus the square root of b squared, so 36, 6 squared is 36, minus 4 times 10 times negative 1. So this is going to end up being a negative 40. So again, I did 4 times the negative 10 times 1 and got me negative 40, and that will end up being addition there in a minute for us. All over 2 times a, or just 2. I then always start inside my radical. So I'm going to do 36 plus 40, gives me the square root of 76. And then we have to find the largest perfect square that goes into 76. Well, the largest one that does is 4. It's 4 times 19. Okay, and so we're going to simplify that. This would be 6 plus or minus 2 root 19 over 2. And then I'm going to simplify the fraction. What we talked about in class, if you remember, if it helps you, split it apart, like so. Give both parts the numerator, your denominator. 6 divided by 2 is 3. 2 divided by 2 gives me just 1, so my answer is 3 plus or minus the square root of 19. One other note I want to make for you before I go on to the next section. If you only have 2 terms, you're still going to set it equal to 0. Okay, you can factor this. A lot of us forget about this. Try GCF factoring, really on both number 15 and number 18 here. That's going to be important for you to be able to finish that problem. These next few here really just combine last chapter with this chapter, and you have to remember how to solve a problem with a square root in it. And what we did is we first isolated our radical. So I'm going to get this x to the other side, so it'll be x plus 2 equals the square root of 2x plus 67. And I'm going to square both sides in order to undo that radical. What's very important, make sure you write this binomial twice and FOIL it. When you square it, you should get that. X squared plus 4x plus 4. Okay, from here you'll set it equal to 0 and do it exactly like the problems we just solved, so I'm not going to finish all the way through. Do make sure on ones like 19 through 22, you need to check your answer. Okay, if you don't remember why, look back into your Unit 2 notes as well as your unit notes over these examples. But do make sure you check on all 4 of those problems. Okay, this next section is converting back and forth between the 2 different forms. When we were converting from from standard form into vertex form, remember that first we're going to separate our first 2 terms from the other one. So if I do 25, I'm going to separate negative x squared minus 2x from the negative 3, because when I complete the square, I really only pay attention to your ax squared and the bx term. Then if you have an a value, you need to factor it out. So here I'm going to pull out a negative from just the first 2 terms, not from this 3. And then we go through the process of completing the square. You're going to take your b value and cut it in half. So 2 divided by 2 is 1. And then square it. So I'm going to add 1. But we need to make sure that we balance it out. We cannot just add something and not cancel it. So we're going to balance it out here. And what we have to think about is what we did to the problem as a whole. So this negative times 1 is really a negative 1 that I added to the whole thing, not a positive 1. So I need to add 1 to cancel it. Your last step then is to factor, and you can do the x for it. Again, I'm going to just write the answer, and this is my final answer. Okay, when you get to ones like 29 and 30, remember to FOIL out your binomial first. If you have something in front, after you FOIL it, you can distribute it, and then combine your like terms. Okay, the next part is where we graphed. And I'll only do one of them. I'll make sure you remember how to do it. Do remember that you can convert between the forms on the equations of your graph. So if I give it to you in vertex form and you would rather graph from standard form, you can expand it out. Or if I give it to you in standard form and you'd rather do it in vertex form, you can put it into vertex form using the method that we just talked about up here. Okay. No matter the way you're doing it, you need to find your vertex first. So if it is given to you in vertex form, you look at how it transformed around. So this one went left 5 and up 1, which means my vertex is at negative 5, 1. If you're given it in standard form, you cannot just look at your equation and see it. You have to use your negative b over 2a formula that we gave you. Okay, negative b over 2a in this problem would be negative 6 over 2 times 1. Again, do the top, do the bottom, 2 times 1 is 2, and then divide. So here my vertex, the x-coordinate, is at negative 3. That number also gives you your axis of symmetry. To be able to graph this, no matter the method, you put your vertex in the middle, and we're going to plug in points to the left and to the right. When you do this, remember that your points the same distance from the vertex will match, so you do not need to plug in all 5. You are just going to plug in 3 of them. Okay, if it is in standard form, you do need to plug it into both spots. Please be careful when you do this that you're doing it correctly. Okay, negative 3 squared gives us 9. 6 times negative 3 is negative 18, so it's 9 plus negative 18, which is negative 9, and then plus 5 gives you negative 4. Okay, when you plug in either negative 2 or negative 4, you should get negative 3, and when you plug in either negative 5 or negative 1, you should get 0. Please be careful plugging those in, and as always, if you need help, come see me. I'm going to talk through your characteristic chart. So for the domain, that is left to right. So the farthest this goes to the left. Again, remember this is left, this is negative infinity, this is positive infinity. Farthest it will go to the left is negative infinity. The farthest it will go to the right is positive infinity. Range is your bottom to top. So the lowest value is this negative 4. And the highest, it's going to go up forever and ever, is infinity. For your limits, below the line, you need to pull down both parts of your domain, so negative infinity, positive infinity. This is the left, this is the right. And then we need to think about where y is going in each of those directions. To the left, my graph is going up forever, so that means this will be infinity. To the right, it is also going up forever. For increasing versus decreasing, think about on your graph which part is which. This right side is increasing, this left side is decreasing, and it switches right at that x value. When you're giving me this interval, do make sure you tell me x values. So for increasing, it starts when x is -3. So it starts right at this line right here at the -3, and it happens forever to the right, so it goes to infinity. For decreasing, it starts way over here forever to the left, so at -infinity, and it stops decreasing at -3. For your x-intercept, if you look at the graph and you can see it nicely because you plotted it, then use it. So on this one, we have -5, 0, and -1, 0. If it does not work out nicely, this is where you do your quadratic formula. You factor whatever it may be. Okay. You will not have y-intercepts on this graph or on this test either, just like last one, so we can focus on those x-intercepts because those are trickier and that's our priority right now. Okay, for the systems of equations, this is where you're just graphing both of the equations for me and checking the answer. So you're going to graph this line, so I'll make sure we remember how to do that, using your y equals mx plus b. So here my intercept is at -2. My slope is a 1. Okay. And it looks like that. Again, I would plot points all the way through in both directions to make sure. For your parabola, you're going to have to make your t-chart. So find your vertex however you want to, whether that's using x equals -b over 2a again, or convert it into vertex form. Then you're going to graph both, and again, check your answers with the answers that are on the back to make sure you're doing it correctly. Last but not least, we have our projectile motion problems to make sure that you can process through those word problems. So I'll talk through again one of them, and then you can make sure you know how to do them and come see me if you need any help. When we're looking at this, again, make sure you're processing what the words mean in terms of your graph. So here I always sketch myself a picture. It doesn't have to be perfect, but that way I can think about it. Okay, on part A, it wants to know how long, so it wants to know the time, or my t value, which is my x, that it takes to reach the maximum height. Well, the maximum height is going to be my vertex. Okay, so that means that to find this t value, I just need to find the x-coordinate in my vertex, which I find by doing -b over 2a, to the equation that they gave me here. When they want to know that actual highest point, you're going to plug in the answer from A, because that will give you figured out in A, you figured out the time to this point, but to figure out the actual height, you just plug it into the equation. So you'll plug that in to your t value in your equation. When I want to know when he hit the water, that means you want to find an x-intercept. So you are most likely with these using the quadratic formula. So the way you find where he hit the ground here, or the water in this case, is by using the quadratic formula. Okay, for your domain and range, he started at time equals 0, and he stopped at whatever the answer for your x-intercept was. So the answer to C in this case. For your range, the lowest he got is the water, so that's 0. And the highest, again, is the answer to B. That's that maximum height that he reached. So you will have to use your answers from these to get your answer for D. Okay, the rest of them work very similarly to that. Again, please, as you go through, make sure you are actually checking your answers using the key provided to you.